Let's look at how to write the equation of a rational function given the graph. So there's a couple key pieces of information that we need to find from the graph. The first thing that we want to look for are any horizontal intercepts. So as we look at this graph, notice that there's a horizontal intercept here at the point 1, 0. And another thing that's important about this intercept is the graph touches the x-axis rather than crosses the x-axis. This is going to be important when we go to think about our exponents for our factors. The other thing that we need to find on our graph are where we have vertical asymptotes. So we have two of them. So we have one here at x equals -3. And the thing to notice about what's happening at that asymptote is that on one side the graph is going up and on one side the graph is going down. We'll talk more about that in just a second. The other one here is at x equals 2, and as we look at x equals 2, notice that the left side is going down and the right side is going down as the graph approaches that. So horizontal intercepts are going to tell us about factors that end up going into the numerator of our function. Vertical asymptotes tell us about factors that are going to go into the denominator of our function. So as we take a look at this, start to write our function. So we're going to have a leading coefficient. We'll come back to that in a moment. So since our horizontal intercept was at the point 1, 0, I'm going to have the factor x minus 1 in the numerator. Because it touched, it's going to be an x minus 1 squared. So we need an even multiplicity when the graph touches at that intercept. In the denominator, since we have a vertical asymptote at x equals -3, I'm going to have a factor of x plus 3. Since we have another one at x equals 2, I'm going to have a factor of x minus 2. The way that we determine if we need any exponents on these factors in the denominator is by looking at what the graph is doing as it approaches that particular asymptote. If you think back to our toolkit functions from back in chapter 1, the graph of 1 over x had one piece that was down and one piece that was up. The graph of 1 over x squared had both pieces up above the x-axis. This is essentially going to be our clue for when we need an exponent. So if as the graph approaches that vertical asymptote, the graph is going in opposite directions, one side is up and one side is down, either way, then that's when we're going to have just a single factor or an exponent of 1. Anytime the graph is going in the same direction, either both sides are going up or both sides are going down as it approaches that vertical asymptote, that's when we're going to need an exponent. So since at x equals 2, both sides of the graph are going down as it approaches that x value of 2, we're going to need an x minus 2 squared. So the last thing that we need to find is our leading coefficient, and this is where we usually use our vertical asymptote. It was given in this problem that our vertical asymptote, this point, is 0, -0.2. So since it was hard to see from the graph, that was stated in this problem. So what we're going to do is we're going to plug in 0 for x and set our function equal to -0.2. So we'll have f of 0 is equal to a, that's what we're trying to find, times 0 minus 1 squared, all over 0 plus 3 times 0 minus 2 squared. This should be equal to -0.2. So we have a times -1 squared is 1, 3 times -2 squared, so 3 times 4 is 12, is equal to -0.2. So to get rid of that 1/12, you can think of dividing both sides by 1/12, or dividing by 1/12 is the same as multiplying by 12 on both sides of our equation. So it tells us that a is equal to -0.2 times 12, so we could write that as -2.4, or as the fraction -12 fifths. So putting that all together, our function is going to be, I'm going to go ahead and use the -12 fifths. -12 fifths times x minus 1 squared all over x plus 3 times x minus 2 squared. So with a rational function, it's fine to just write the leading coefficient out in front of the function like that as a leading coefficient. If you wanted to put the negative 12 in the numerator and the 5 in the denominator, that would be fine as well. It would also be fine to write that as a negative 2.4 out in front. So really the key part on this one that makes it a little bit more challenging are those exponents. So we need an exponent of 2 in the numerator, because that horizontal intercept is a place where the graph touches the x-axis. We need an exponent of 2 in the denominator on the factor of x minus 2, because at that vertical asymptote we see the graph is going down on the right side and down on the left side, which is different than our other vertical asymptote where one side goes up and one side goes down.